Okay, so this video clip is about assigning oxidation numbers. So using the rules that were in the previous video, keep your book open beside you with the rules in them, and then we'll go through each one. You can check back on it later. So I'm going to first of all start with NO2, nitrogen dioxide. I'm going to assign oxidation numbers to each element. So I don't know what nitrogen's oxidation number is. I know that oxygen has an oxidation number of -2. There are 2 of them in this compound. There's an overall charge of 0 on the compound, which means that nitrogen -4 is equal to 0. So in this particular case, nitrogen is +4. N2O5, again, don't know what nitrogen is. There's 2 of them, and there's 5 oxygens, which of course are -2, overall charge of 0. So this gives me 2 nitrogens minus 10 is equal to 0. So in this particular case, 2 nitrogens equals 10. Each nitrogen must be +5. If I look at HClO3 and look at the oxidation states of each element here, hydrogen is +1. Chlorine I'm not too sure about. I've got 3 oxygens or 3 -2s. Overall charge on that compound of 0. So this will give me chlorine -6 plus 1 is -5. So chlorine -5 has an overall charge of 0. Chlorine must be +5 in this particular case. Let's look at HCl on its own. Hydrogen is always +1. In this particular case, chlorine, in order to give an overall charge of 0, will have to be -1. Let's have a look at nitric acid, HNO3. Again, hydrogen is +1. Nitrogen I'm not too sure of, but I've got 3 oxygens which are -2. Overall charge of 0. So this will give me +1 minus 6 is -5. So nitrogen -5 is equal to 0. So in this particular case, nitrogen is +5. Potassium permanganate, KMNO4. Let's assign oxidation numbers to everything here. Potassium is in group 1, so that's +1. Manganese I'm not too sure of. I've got 4 oxygens which are 4 -2s, overall charge of 0. So +1 minus 8 is equal to -7. So Mn -7 is equal to an overall charge of 0. Mn must be contributing +7. Iron oxide, or iron hydroxide rather, OH2. OH3. OH, if you remember from our anion testing, has a valency of -1. So these OHs are contributing -1, and you've got 3 of them. So this is iron plus 3 -1s is equal to 0, because there's an overall charge of 0 on that compound, which means that in this particular case, Fe -3 is equal to 0, so Fe must be +3 here. Look at iron sulfate, FeSO4. If you remember again from our anion testing, SO4 is -2, has an overall charge of -2. So this is Fe plus just 1 -2 gives me an overall charge of 0 on that compound. So in this particular case, iron has to be +2. Now just in passing, where does this -2 charge come from on sulfate? No idea what sulfur is, but I've got 4 oxygens which are -2. So sulfur which gives me an overall charge of -2. Sulfur -8 is equal to -2. So sulfur is equal to +6 in this particular case. So in this compound, iron is +2, sulfur is +6, and of course oxygen is -2. Potassium dichromate is K2Cr2O7. Let's have a look at the oxidation states here. 2 potassiums is 2 plus 1. 2 chromiums is 2 Crs. 7 -2s. And I've got an overall charge of 0. So this will give me 2 chromiums. -14 plus 2 gives me -12. Overall charge of 0. 2 chromiums must be equal to 12. So each Cr has to be +6. And it's each atom that you need the oxidation state for. So looking at this compound, chromium is +6, potassium is +1, and oxygen, of course, is -2. If we take hydrogen peroxide, H2O2, hydrogen is always +1, so that's 2 +1s. Oxygen is in a peroxide here, so we're not too sure what it is when it's in a peroxide. So we're going to say 2 oxygens equals an overall charge of 0. So this is 2 plus 2 oxygens is equal to 0, which means that 2 oxygens equals -2. So each oxygen atom now, this time, is -1. So this is your peroxide form. OF2, let's have a look here. Fluorine is the most electronegative element in the periodic table. It's always -1. So oxygen might vary here. So oxygen plus 2 -1s is equal to a 0. So this gives me oxygen -2 is equal to 0. So therefore oxygen is equal to +2. So my oxygen atom has a oxidation state of +2 in this case, which is completely different from its usual. Let's look at sodium sulfate, NaSO4. Sodium sulfate assign oxidation numbers. So for this particular one, we've got Na is +1 because it's in group 1. Sulfur I'm not too sure about, and I've got 4 oxygens which are -2. Overall charge of 0 on that. So sulfur, this gives me -8 + 1, which of course is -7. So in this particular case, sulfur is +7. And finally, if you look at the sulfate ion, SO4, 2 minuses. In this particular case, what's sulfur? So sulfur plus 4 -2s gives me an overall charge of -2, which is appearing on that ion. So in this particular case, sulfur is equal to -2 plus 8. So here, sulfur is +6. So now try the exercises at the back of the chapter of oxidation reduction. Look at the relevant ones about oxidation numbers and see how you get on.